All right, today we're going to go through P.8, and we'll start off with this bell work. If you haven't tried this bell work, go ahead and pause the video here so that you can give it a try. If you would like, you can also give each example a try before you watch through this as well. Okay, so here we're just performing the given operations. So we have both addition and subtraction here. So in order to do that, we must have a common denominator. In this case, we kind of need to factor everything out. This is done. This is x plus 1 squared. So we have x plus 1, x plus 1. So that's factored out. And here we have a difference of squares. So x plus 1, x minus 1. Okay, so our common denominator needs to be the same all the way through. And for that to happen, we're going to take an x plus 1, another x plus 1, because we have two of them here, and the x minus 1. So we're going to multiply each by what they're missing. So this middle one's missing the x minus 1, so that gets that in the bottom and the top. This one's missing an x plus 1, so that gets that in the top. And the first term here is actually missing both x plus 1 and an x minus 1. So x plus 1, x minus 1. In the bottom, we're going to leave it all the way factored out. So we're going to leave it x plus 1, x plus 1, x minus 1. In the top, we need to go ahead and distribute and combine like terms. So this x plus 1, x minus 1 multiplies to x squared minus 1, the difference of squares. Don't forget this negative right here. You're going to use this as a negative 2 and distribute in. So you have minus 2x plus 2. And then you have a 3, so plus 3x plus 3. When you reduce or combine like terms here, you have x squared. Negative 2x plus x is x. And then negative 1 plus 2 is 1. 1 plus 3 is 4. And then factors of 4 that add to 1, there aren't any. So then you can't cancel anything, or you can't refactor that. So you get x squared plus x plus 4 all over x plus 1 squared, x minus 1. If you can refactor the top, refactor it, see if anything will cancel. Also, you may want to note your excluded values, or what x cannot equal. So in this case, it's plus and minus 1. All right, now P8 is solving basic equations. And when we say the word basic equations, we mean basic for like Algebra 2, college algebra level. Okay, so we're going to refresh and expand our equation solving skills. Just remember that we're undoing the order of operations. So we're going this direction. Okay, instead of down, we're going up. You also need to check. We're getting into some harder equations now that may have some excluded values. So you're going to need to plug those back in and make sure that they work. All right, so we're going to start off pretty easy and then just ramp it up. So we have a linear equation here. To solve a linear, you just get x on a side all by itself. So we're going to subtract 3x, and we're going to add the 4 to the other side. So 7 minus 3 is 4x. 8 plus 4 is 12. You get divide by 4, and you get x equals 3. Now with linear, it's not as important that you check them. And we'll kind of talk about restricting the domain so we don't have to check. But there's really no bad values or domain restrictions on this one. So if you plug it in, as long as you do your math correctly, you plug it in, you'll get a true statement there. Okay, here we are involving fractions. So most students do not like to deal with fractions. So what we're going to do is, first thing, we're going to get rid of every single fraction here. And x is not in the denominator anywhere, so I don't need to worry about restricting my domain. So in order to get rid of these fractions, I can multiply by my common denominator. In this case would be 12. And then I'm going to take 12 times each one of those fractions. So I'm going to take 12 divided by 6, which is 2, and 2 times x is 2x. And we'll take 12 divided by 3 is 4. 4 times 2 is 8. And that's the same. If you want to take 12 times 2/3, that's the same. Like in the calculator, you'll get the same answer. Remember, we divide by the bottom and multiply by what's on top. So 12 divided by 4 is 3. 3 times 3x is 9x. And now we're left with a linear equation. We can just subtract the 2x. So you get 8 equals 7x divided by 7. And x equals 8 over 7. Again, you could plug that into a calculator and check that solution if you would like. Now here we have, x is in the denominator. So we're going to look at what x cannot be. So we need to keep in mind our excluded values, because if I get that answer, then I have to get rid of it. So the first thing here is to factor everything. So I got x plus 1, x minus 2. I need factors of 2 that subtract a 1. That's 2 and 1. So x minus 2, x plus 1. Signs are different. The bigger one's negative. Okay, so this helps me figure out what x can't be. It can't be -1, and it can't be 2. Just looking at the denominators all the way across there. I can still multiply by my common denominator, which is x minus 2, x plus 1, to remove the fraction. So when I take this times each quantity in here, whatever's on bottom is going to cancel. So my x plus 1, those cancel. I get x minus 2 plus, and then my x minus 2 in this middle one cancel. You get x plus 1. And then on this one, both of them would cancel because I have both factors, and I just get x plus 3. And then I look, do I have anything to distribute? Combine like terms. So nothing to distribute, so we don't worry about the parentheses. So I have x plus x is 2x. -2 plus 1 is -1. X plus 3. So we'll subtract x, add 1. So you get x equals 4. And if we look back up here at my excluded values, 4 wasn't in those excluded values, so I can actually have that as a number. If I was to get like a -1 or a 2, there wouldn't be a solution because I would have to mark it out. And that happens a lot when you get 2 or 3 solutions down there. One of them might not work out. Okay, here's the same kind of thing. That 2 at the front, we can put this 2 over 1 to treat it like a fraction. X cannot equal 4 here because here I don't need to factor anything. So we're going to go ahead and multiply by what's on the denominator to get rid of it. So when I do that, nothing cancels here. So I have 2 times x minus 4 plus your x minus 4 cancels there. You get 5. The x minus 4 cancels here, so you get x plus 1. So we'll go ahead and distribute the 2. So 2x minus 8 plus 5 equals x plus 1. Combine like terms. So let's subtract x, subtract x. This would be a -3. So we're going to add 3 and add 3. So this cancels and this cancels. So we get x equals 4. But if we look here, we said at the beginning that x could not equal 4. So in this case, there's no solution. Because if I were to take that 4 and plug it back in, I get 0 right here on the bottom. I get 0 right here or 0 right here. That's undefined. I cannot have that. So there's no solution here. There's no number that I can plug in for x to make the left side equal the right side. Okay, with powers, in order to undo certain powers, you can do a couple things. You can take the roots, so the matching root, like here on A and B, I have a square root that I would take on each, or you can take it to the reciprocal power. So if it's something like x to the 2/3, we can raise both sides to the 3/2. Those cancel each other out, giving you 1, and we can do it that way. The big thing is I have to isolate the exponent first. So here in A, it's not isolated. So the first thing I have to do is add 5. So you'd get x squared equals 5. And then we're going to take the square root. And anytime you take an even root in solving, you're going to have a plus minus. So here x equals plus minus the square root of 5. Down here, the radical is already, or not the radical, the exponent here is already isolated. So we're going to square root it right away. So I get x equals plus minus the square root of 5. Whoop. That'd be x minus 4 over there. And then the last thing I have to do is add the 4. So x equals 4 plus minus the square root of 5. And we don't want decimals on these. We want exact radicals, so no need to use the calculator when solving these. So some additional, again, all real. So here we have x to the 3rd equals 8. So we're going to take the 3rd root. And the 3rd root of -8 is actually -2. So with odd radicals, you can actually have positive and negative numbers. The first thing here, we need to divide by 16. And 81 divided by 16 is a fraction. It doesn't divide evenly. So we're going to leave that as 81 over 16. Now we have the 4th power, so we're going to take the 4th root. And that's an even root, so we have plus minus. And you can take the 4th root of the top and the 4th root of the bottom separate to make it kind of easier. So then we're asking what times itself 4 times is 81. That's 3. And what times itself 4 times is 16. That's 2. So then you get both the positive and the negative 3/2. Okay, here you see our fractional power here, which is really a radical, but we don't have to turn it into a radical if we don't want to. The first thing is going to be isolate that radical or that term. So we're going to add 2. We have 5x to the 2/3 equals 45. Then we'll divide by 5. X to the 2/3 equals 9. And in order to get rid of that, if I take both sides to the 3/2, these will cancel. So you get x equals 9 to the 3/2, which if we rewrite that with a radical, that's the square root of 9 to the 3rd, which is the square root of 9 is 3. 3 to the 3rd is 27. You actually, if you take 9 to the 3 halves on the calculator, you'll get the exact same answer. But this is showing some more work here on this problem. And if you wanted, you could plug that back in for x and check your solution. We don't have to have any numbers in the equation to solve for it. I call these abstract equations. There's no numbers really for letters. It's a formula. Okay, so this is a formula, and it says solve for the variable capital M. You'll notice there's 2 M's in here. So if I solve this for M, we can kind of rewrite it. So this G is kind of out in front. I'm going to go ahead and rewrite it with that G on top. So GMM over R squared. That just makes it easier, one fraction here. To isolate this M, we're going to multiply by R squared. So I have F, capital F, R squared equals G little m, capital M. And we're solving for capital M, so now I just need to divide by G and the little m on both sides. Make sure when you do this, you can get some of those complex fractions that we did the other day. Just make sure that you get rid of those. You can only have one fraction in your equation for these types of problems. And scientists use kind of this method a lot. You know, if they want to rewrite a formula for, I don't know what this would be, maybe magnitude or mass of some sort, or they do the same kind of thing with Celsius and Fahrenheit, those formulas. Okay, so solving for one variable in terms of others. So the surface area of a closed rectangular box can be calculated, and I don't have the figure there for you, but it showed you a figure. Can be calculated from the length, the width, and the height according to this formula. So they give you this formula here for their rectangular box. It looked something like this, and it had sides labeled on it. Okay, this was a side, this was a side, and this was a side. Solve for W in terms of the other variable. So we're solving for this W, and there's actually 2 of them there. Okay, so this gets a little tricky. So if I rewrite the formula, 2LW plus 2WH plus 2LH. If we look at the formula, we have 2 W's in there. That's the width. So you get the width, the length, and the height. So what I need to do is both of those terms I need to isolate. So we're going to move this to the other side. So you have A minus 2LH equals 2LW plus 2WH. And because I want to solve for the little w only, we're going to take and we're going to factor out that little w. So we have w parentheses 2L plus 2H. Area equals 2LH. Whoop, area minus. And then all I have to do is divide by what the w is with. So we're going to divide by 2L plus 2H. Divide by 2L plus 2H. So W equals, well, it's more of a little w. W equals area minus 2 length times height over 2 length minus 2 height. That is W in terms of the other variables. So if you wanted W, you needed to have the area, the length, and the height, and then you could find the width. Okay, so your assignment is solving some equations, P.8 on WebAssign. So once you get that, make sure that you submit a picture onto Schoology so that I can get you some credit for it. If you got questions, feel free to reach out.